Welcome to the chemistry studio. Today's topic is VBT. Before learning VBT, we must know about spectrochemical series. In this series, weak ligands and strong ligands they are separated by ammonia. The ligands before ammonia are generally weak and the ligands after ammonia are generally strong. The ligands after ammonia are En, NO2 minus, Cn minus and carbonate. Right? As far as ammonia is concerned, if ammonia is bonded with metal having +6 oxidation number, coordination number, then if it shows +2 oxidation state, it shows +2 oxidation state or +3 oxidation state. With +2 it is weak, but with +3 it is strong, and with coordination number 4 it is always weak. You will remember this. Let us take an example of NiCN whole 4 2 minus. Cn is strong ligand, we know. First of all, write the central metal atom and its atomic number. Now the configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. We will write only the valence shell. The valence shell is 4s2, 3d8. You will write third shell first and after that the valence shell. 4s. This is 3d, this is 4s. In fourth shell there is p also. There is d also, but they are unoccupied. In 3d there are 8 electrons: 1, 2, 3, 4, 5, 6, 7, 8. In 4s there are 2 electrons. Now find the oxidation number of this central metal ion. Let nickel be X plus cyanide -1 into 4 is equal to -2. So X will come out to be +2. It means nickel will be losing 2 electrons. The 2 electrons, we will remove them from the valence shell only. It means from the 4s. One, 2, 3, 4, 5, 6, 7, 8. Now this nickel 2 plus will combine with 4 cyanide to form complex. Cyanide is a strong ligand. It will cause pairing. It means these electrons will get paired. All the strong ligands will cause pairing. You will remember, in case of strong ligand, we will pair the unpaired electrons. But in case of weak ligands, there will be no pairing. It means it becomes. Now we have these empty orbitals. Cyanide will donate its lone pair in these vacant orbitals. There are only 4 cyanide, therefore The hybridization becomes, this is d orbital, this is s, and these are 2p orbitals. The hybridization is dsp2. Right? Hybridization is dsp2, and geometry is square planar. Structure is now the magnetic behavior. As you can see that in this case there is no unpaired electron. If there is no unpaired electron, it means it is diamagnetic in nature. Diamagnetic. They are weakly repelled by magnetic field. We can also calculate the magnetic moment mu is equal to n plus 2. But this is the limitation of VBT. VBT did not calculate the magnetic moment. Unit is Bohr magneton, where n is the number of unpaired electrons. And there is no unpaired electron, therefore the magnetic moment comes out to be 0 in this case. Again, NiCl4 2 minus. We are taking chloride instead of cyanide. Again, we will go with the same procedure. Nickel 28, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Nickel, valence shell. First we will make third shell, then fourth shell, because the fourth shell is the valence shell. This is 3d, this is 4s. In 3d there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. In 4s there are 2 electrons. This is 4p and 4d. They are unoccupied. Now again the oxidation state of nickel in this case is plus 2. Nickel plus 2. It means it will be losing 2 electrons. We will remove the electrons from valence shell, that is 4s. 1, 2, 3, 4, 5, 6, 7, 8. 2 इलेक्ट्रॉन निकाल दिए हमने. Now nickel will combine with 4 chloride. As you know that chlorine, this chloride is a weak ligand, therefore no pairing will take place. Now we will have to fill the lone pairs in these vacant orbitals. Cl lone pair, lone pair, lone pair and lone pair. This is s orbital, these are 3p orbitals, therefore hybridization will be sp3, and geometry is tetrahedral. Geometry is tetrahedral. Now, as you can see, there are two unpaired electrons. It means the magnetic behavior is paramagnetic. Magnetic behavior is paramagnetic. Paramagnetic. Paramagnetic means weakly attracted. Weakly attract in magnetic field. The structure is you can also calculate magnetic moment. Mu is equal to square root n plus 2 Bohr magneton, and the value of n is 1, 2. I hope it is clear to you all. Now taking another example. H2. H2 is a weak ligand. H2O is a weak ligand. Again, nickel 28, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8, nickel, 3d, 4s, 4p, 4d. This is 3d, 4s, 4p, 4d. In 3d there are 8 electrons. पीछे भी पढ़ा हमने. And the oxidation state again in this case is +2. +2. It means it will be losing 2 electrons from 4s subshell. Four, 5, 6, 7, 8. Now it will combine with 6H2O. H2O is a weak ligand. No pairing will take place. Again, it means H2O will donate its lone pair in these vacant orbitals. H2O lone pair, H2O lone pair, H2O lone pair, H2O lone pair. As you can see, the hybridization is, this is sp3d2. Hybridization is sp3d2. sp3d2. sp3d2, it means geometry is octahedral. And magnetic behavior, as you can see, it has 2 unpaired electrons, therefore it is paramagnetic. And now the structure. It is octahedral. Octahedral means it has 8 faces. Magnetic moment, mu is equal to square root n plus 2 Bohr magneton, and value of n is 2 again. Taking one more example, NiCO whole 4. Carbonyl. Carbonyl is a strong ligand. Nickel. 28, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Oxidation state of nickel X plus 0 into 4 is equal to 0. X comes out to be 0. Nickel has 0 oxidation state. Nickel 3d, 4s, 4p and 4d. 1, 2, 3, 4, 5, 6, 7, 8, and it has 2 electrons. Now nickel, there is the oxidation state of nickel is 0. It means we need not remove the electrons. But CO is a strong ligand. It will cause pairing. So these 2 electrons, they jump back in the 3d orbital and get paired. Now nickel combines with 4 carbonyl . 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D is fully filled. Carbonyl will donate its lone pair in 1s and 3p. Therefore, the hybridization will come out to be, as you can see, sp3. Hybridization sp3. Geometry tetrahedral. Magnetic behavior. Magnetic behavior. All the electrons are paired, therefore diamagnetic. Now the structure. Tetrahedral, as you all know. This is tetracarbonyl nickel. Now taking another case, Cu NH3 whole 4 2 plus. This is an exception. Copper 29. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. As you all know, that this is an exceptional case. One electron jumps from 4s to 3d. Now copper, third shell, fourth shell, 4s, 4p, 4d. The oxidation state of copper in this case, as you can see, is +2 because amine carries no charge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 1. Now we need to remove 2 electrons. One, 2, 3, 4, 5, 6, 7, 8, 9. 1 electron from 4s and 1 electron from 3d. Now, it has been told that the hybridization of this complex is dsp2. We have been told it that it has hybridization dsp2. Experimentally, it has been observed. It means this 1 electron will jump into the vacant p orbital. The reason is because it has square planar geometry. So in order to make it dsp2, we need to jump this electron into the vacant p orbital, and when it combines with 4-amine, the hybridization comes out to be dsp2. One, two, three, four, five, six, seven, 8, and this is one unpaired electron. 4ns3, they combine like this. Lone pair, they donate lone pair, and the hybridization is dsp2. Geometry is square planar, and magnetic behavior paramagnetic. Structure square planar geometry, ns3, 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 2 plus. I hope it is clear. Now next is the limitation of VBT. Limitations of VBT. First point, it did not distinguish between strong field and weak field ligands. Next point, it did not distinguish between tetrahedral and square planar geometry. Next point, it did not calculate magnetic data. जो हमने म्यू कैलकुलेट किया मैग्नेटिक मोमेंट, वो वीबीटी ने कैलकुलेट नहीं किया था. It did not tell anything about काइनेटिक्स मतलब किस रेट पर बने हैं, एंड एनर्जेटिक्स मतलब कितनी एनर्जी एब्जॉर्ब या रिलीज हुई है ऑफ द कंपाउंड्स. That is all for today. Thank you for watching.